Now, you'll notice in this system, look at this first equation and the second equation and compare them. Look at this x. This one is triple for the y, and triple for the constant. So what we've done is we've taken the first equation and just multiplied everything by 3, right? Triple, triple, triple. So this second equation is really not a new independent equation from number 1. We really have just one equation. So what we're expecting here is, well, let's just say it. We are expecting no unique solution, because what we've got are coincident lines. This second line is really just another way of writing the first line. Let's just see what would happen if we didn't recognize this and we went ahead about our business and we decide we're going to eliminate y and get x. So let's just do this part right here. So to eliminate y, what I'm going to do is I'm going to focus in on the y's and try to get these to be the same coefficient but opposite signs. So I got a 4 and a 12. The smallest number they divide into is 12. Now I can make this a 12 if I multiply it by 3, but because they have the same sign, I'm going to need a negative multiplier because I want this to be a positive 12. So the plan is to multiply the top equation by negative 3. So if I do that, here's the strategy. Negative 3 times equation 1, right? Because negative 3 times this will give us positive 12. With a negative 12, that'll go to 0. And then all I have to do is add equation 2. I don't have to do anything to equation 2 because this is already a 12. So let's see what this looks like. Negative 3 times equation 1. So take a negative 3, multiply it all the way through equation 1. That'll give us negative 3x plus 12y equals negative 15. Right, let's just check that. Now let's add in equation 2, which is 3x minus 12y equals 15. And when we add these together, the x's are gone, the y's are gone, and the constants are gone. So we end up here with 0 equals 0, which is a true statement. So we've eliminated all the variables and we're left with a true statement. So what that tells us is that we have, I'll write it here, we have coincident lines, which means that we don't really have two lines, we have one line. We have another line that blends into the first line, and this means we have no unique solution. If we were to graph these two lines, we'd see that we graph one and then we graph the other, and it's the same line. So it's just no unique solution. Now in this system, this is going to be similar to what we did in problem 43, but look what we did. Well, look what we did in 43. Here's what we did. We tripled, tripled, tripled. Now we could have doubled, 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 quadrupled, 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 but we tripled, 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 and we ended up with coincident lines, no unique solution. Now look what we're doing here. This is the second equation is 4 times this, and then not 4 times this. So what we're doing is we quadruple, quadruple, and then we don't quadruple. So back over in 43, we picked a multiple, 3 times 3 times 3 times 3, triple, triple, triple. Now over here we pick a multiple, 4, and we times 4 times 4, not times 4. So in this case, we are expecting no solution. These lines are going to be parallel. Now, if we don't see it and we go about our business, we're going to try to eliminate y and get x. It's going to look almost like that problem 43. And here's our plan, right? We're going to eliminate y, so we're going to focus in on these y's. Now, the smallest number that both 4 and 16 divide into is 16. So we're going to make these 16s. Now, all I have to do to make this a 16 is multiply it by 4, but because they have the same sign, I want an opposite. I'll multiply it by negative 4. So the plan, the strategy is negative 4 times equation 1, then I'm going to just add equation 2, right? Because equation 2, I've already got a 16. I don't have to do make any multiplications there. So here's what this is going to look like. Negative 4 times equation 1 is going to be negative 4x plus 16y equals negative 20. Let's just check it. Negative 4 times equation 1. Negative 4x plus 16y equals negative 20. Let's add in equation 2, so that's going to be 4x minus 16y equals 1. And when we add these together, look what happens here. The x's are gone, the y's are gone, but the constants are not gone. So what we end up with is on the left side, we end up with 0 equals, on the right side, negative 19. So we've eliminated all the variables, but in this case, we got a false statement. Back in problem 43, right, in 43, we got a true statement. We eliminated all the variables. Result is true. No unique solution. The lines are coincident. But over here, we've got eliminated all the variables. We got a false statement. That means that we have parallel lines, and parallel lines mean, they never intersect, so we have no solution.